Well, I don't think you guys have any papers?
You don't follow.
Everyone on the team did it.
Now we're good for here. Right.
I think we all need
Okay, thank you.
You need more pens? You're good? Okay.
Yes, that's
Hoping that I feel like as so in terms of like the field, is it? It's a big like Gurdemir where it's located. Yeah, because I saw Rocky Park. So it's when you the way that I did it. Because I get there, I come from, I go 28 to 287 to 30.
Hold on to it, you may have more. We'll come around and collect the cards for questions, so hold on to your question. Hold on to them until like 45 minutes from now. It is. All right, good evening, everybody. How are we doing? Good? Awesome. Well, welcome to the Exploring the Eclipse panel, sponsored by UTA and the Dallas Morning News. My name is McKenna Dowd. I'm the program coordinator here for the UTA Planetarium, and I'm so excited to welcome you all to our facility. You guys are currently sitting in one of the largest planetariums in North Texas, and a 60-foot dome that can sit up to 150. You guys have it all to yourselves today as we explore the eclipse in depth, right? Now we do have the most updated planetarium software with Digistar 7, so it is wonderful to have you all here today. Now this is really exciting because we have a total solar eclipse coming up. Now eclipses happen all the time, but they don't necessarily happen over a place with this many people over such a big city, so this will be really, really exciting. Now the planetarium, we will have some events coming up prior to the eclipse. We will have an observing event, as well as a concert, as well and special planetarium shows relating to the eclipse. So we hope to see you all there, as well as a solar-bration the day of the eclipse, where we will all turn to the sky and view the eclipse together. This once-in-a-lifetime historic event, absolutely. But so now the reason we're all here tonight, we have an exciting, informative discussion in store tonight, right? It is my pleasure to turn the program over to the moderator of tonight's panel discussion, Adithi Ramakrishnan, who has a degree in neuroscience from the College of William and Mary. She has previously written for North Carolina Public Radio and the National Association of Science Writers. And she now serves as a science reporter fellow at the Dallas Morning News. So please join me in welcoming Adithi. Awesome. Can you guys hear me okay?
Yes.
Okay. Thank you so much, McKenna, and thank you guys all so much for coming. We are all so excited about the eclipse and so excited that you guys have come to join us to kind of go through some of the basics of what this event is all about and how we can all get prepared for it since it's coming up in just a few short months. So yeah, we're going to open up with some discussion between our panelists, and then we will have some time to take audience questions at the end. So if you got a slip of paper, feel free to write a question down on that, and closer to when the discussion is wrapping up too, we'll have volunteers coming around to collect those so that we can ask those later. Perfect. So before we get started, I'd love to introduce the panelists that we have here. So we have Levent Gurdemir. He's the director of the UTA Planetarium, and author of many peer-reviewed articles on astronomy, and also a member of the International Planetarium Society. We have Dr. Kimberly Breuer, associate professor of instruction and history, who specializes in the history of science and technology, and her current research focuses on UT Arlington's celestial map collection. We have Dr. Yue Deng, a distinguished professor of space physics in the Department of Physics, and her research interests include global 3D modeling of the upper atmosphere and space weather prediction. And we also have Dr. Erin Carlson, a clinical professor in the College of Nursing and Health Innovation, and she's the founding director of graduate public health programs. So we're so excited to have all of you here and kick off this discussion. So the first question that we're going to discuss is just why is it such a big deal that the solar eclipse is coming to the DFW area? So, Dr. Deng, would you like to kick us off on that?
Sure, my pleasure. The April eclipse is very special since it will last longer and will feature more active sun than the previous one in 2017. First of all, the totality will last 4.5 minutes, which is 2 minutes longer than the previous one. And meanwhile, the sun is approaching solar maximum now, which means more bright streamers will extend it from the solar atmosphere, corona, which is the outer layer of the solar atmosphere. So that's more active, more exciting things are waiting for us.
Awesome, yeah, so we're looking at potentially a longer or even more bright and exciting eclipse coming up. And Dr. Gurdemir, would you like to add on to that?
Usually this question has been asked a lot of times to us, what's the big deal? So how many of you actually seen or experienced a total solar eclipse before? Well, that's quite some number too, and probably that's the reason you are here, you have an interest, but when you ask this question outside in the public, usually the number of experiencers are pretty low. So this is a very rare event, so the media likes talking about rare celestial events a lot, so every time there's a super moon, we get a call, an interview, 5 times a year. So this is what they call rare, but this is going to be a rare event for Dallas-Fort Worth, so we'll talk about this. It's not actually rare. The solar eclipses are not rare. I reject that. But it's going to be rare for Dallas-Fort Worth because do you know when was the last time it happened in Dallas-Fort Worth area?
1876, 78.
But the total solar eclipse, not the partial eclipses. Okay, so that's, usually the average frequency is 400 years. So when it happens to some place, you have to wait another 400 years if you have patience for that. This is what's the big deal.
Yeah, and I heard 1878 out there is the last time, which is a long time ago. Dr. Brewer?
And the one before that was in the 1600s. And the next one here is going to be in about 300 years. So unless you want to drive north to Oklahoma in about 20 years, you can see it again. So it's very rare for here, but not in general.
Awesome, and Dr. Carlson?
So I'm an infectious disease researcher, so I obviously don't have the expertise about astronomy as my colleagues here do. So I really represent a layperson's perspective on this question. I'm really here to represent the health and safety aspects. So as a layperson in the community, I am so excited about this eclipse because like my colleague said, it is so rare for us to be able to view this, to be in the path in Dallas-Fort Worth, and such a rare thing to get to see, to be in the path of an eclipse without having to travel. So it really is once in a lifetime. And as a global health professor, something else I think is really remarkable is that 3 different countries, all of North America, Canada, the US, and Mexico are all in the path of this eclipse. So how extraordinary when we're viewing this to know that all of the countries of our continent will be able to be part of this. And I think there's something really unifying about that. And finally, I'm really excited about it because I think it's a beautiful reminder of how big the universe is beyond our country, beyond our continent, beyond Earth. It's a really fantastic reminder of the beauty of the universe beyond us.
Yeah, it's really exciting and a unifying moment for kind of all of us to look up at the sky and experience something so exciting here. Yeah, and let's try to get into some of kind of the basics of what causes an eclipse as well, so that we kind of know what we're looking at. So yeah, I mean, Dr. Gurdemir, I'd love for you to get into just kind of what causes a total solar eclipse, what makes that happen in the sky.
Now, apparently it is caused by the moon, the natural satellite of our lonely planet. So the moon goes around our planet, orbiting all the time. So in the new moon phase, the moon is on the side of the sun. It is actually not in the sky during the nighttime, so we don't see the moon in the sky at night. And we don't see the moon in the sky during daytime too, but it's in the sky. But there is light, the sunlight overcomes and then doesn't allow the moon to be visible if the angle is not right. So anyways, the moon passes near the sun all the time, every day, during the new moon phase. So, and sometimes there is an alignment, and that alignment allows the moon block the sunlight partially, or sometimes entirely. And when it is entirely blocked, we call it total solar eclipse. And during the total solar eclipse, the moon's shadow falls on surface of Earth. So this is what causing the solar eclipse. The total eclipse is the moment when the sunlight is completely blocked by the moon.
Yeah, and clearly that special alignment doesn't happen so often, or I guess happens about every 18 months, but in one particular place. It's very rare.
Well, actually, if you wait like 18 months, approximately every 18 months, there is a total eclipse somewhere. But the problem is the moon's shadow is so narrow. The path, for example, this upcoming eclipse, the path of the shadow is going to be roughly about 100 miles wide. So this is nothing comparing to the atlas of Earth. So you cannot see the solar eclipse from any place on Earth. They are not like lunar eclipses. Lunar eclipses are different. So you have to be on that path. But where that path is going to be, if it's happening every 18 months, I can go and catch an eclipse. Well, in theory, it is true, but in practicality, it's not practical, because if it is like in the middle of ocean, or you have to climb up a high mountain. For example, the next solar eclipse after April 8 is going to be visible from Iceland. Well, if you can travel to Iceland, you can catch that eclipse too. But it will require traveling and sometimes to a remote location or hard to access locations. It is important whenever it is like happening in DFW. You have the major airport, major international airport nearby. You have a lot of hotels and great dining and other touristic attractions. So this makes it actually perfect eclipse, probably of the decade.
Awesome. And just to check, can you guys hear all the panelists well?
Yes.
Okay, perfect. So,
Louder.
louder in the back? Okay.
Yeah.
Please.
Okay, we can all be a little bit louder then.
Slower and louder.
Okay, we can do that. So yeah, and just for our panelists, I'd love to see a show of hands of who has seen a total solar eclipse before. How did you guys? Dr. Carlson, have you seen anything?
Yes, I saw it once, but haven't studied it. Like
Yes, but have you been witnessed
Yes,
before? Well, awesome. So, I mean, Dr. Carlson, would you tell a little bit about what your experience was like seeing one as an observer and just what it felt like?
It was you're awestruck, right? Because again, it's this reminder of the universe and how large it is. But in that moment, everything goes a little bit dark, and it feels like night is falling, but it's not. And it's, I think, a really, it's a beautiful sight as well. It's very beautiful. So really look forward to it. And I think it's also interesting the reaction of animals, you know, because they think that night is starting. So animals will start into their, like the things they do at night. Like for instance, you know, Nebraska farm girl here, like dairy cattle, for instance, will change their behavior during an eclipse to actually be what they would be doing at night. And so you might also notice your pets kind of change their behavior just a little bit as well. So those are the kinds of observations when you look at nature and how it's responding. I think that's also very interesting.
Absolutely, and for some of you guys that haven't seen one yet, what are some of the things that you're looking forward to experiencing at this first time? Dr. Deng, do you want to take that one?
My experience?
Yeah, what you're looking forward to seeing this eclipse.
Unfortunately, I haven't experienced any solar eclipse yet. Definitely, I'm so looking forward to this magnificent natural phenomenon for sure. I heard from my friends, it's just speechless. So I leave it to everybody to experience that.
So, and Dr. Breuer, what are you looking forward to, or where are you planning to see it from?
Probably somewhere around here, but I've told Dr. Deng I'm going to go watch her do her science during the eclipse, I think. I've been in a near total eclipse, like just off of that path before, and I just want to see how dark it really gets, and I really want to see that corona. That's what I want to see. And I want there to be no clouds.
Yes, we're all hoping for clear skies. Awesome. So I feel like the next big question is just where we can see this in Dallas-Fort Worth. So love to just get into kind of where we'll be able to see it and where the path of brutality extends in the area. So Dr. Gurdemir, would you like to talk about that a little bit?
Sure. So the eclipse is going to be visible from most parts of the Dallas-Fort Worth area, so you don't need to travel far. It will cover most of Fort Worth, so a major metropolitan area of Dallas, and even further extend to some the 45 and east of 45 is in the coverage. So I mean, it's just happening right above us. That is great. It's going to extend towards south to Hillsborough. It will include Austin as well, especially Round Rock area. Those are going to be on the totality path. So Dallas-Fort Worth area is going to be, I think, the one of the best places in the state, in Texas part, because of accessibility, because of number of hotels, number of accommodation. I heard in many major cities outside of Dallas-Fort Worth area, the hotels are already sold out. Events are already sold out, so people are having trouble finding places to go. But still, there is room in Dallas-Fort Worth. And I know from the fact that we are getting a lot of calls from tour operators, and still they are coming and they are booking the accommodations in the area.
Awesome, and yeah, it seems like pretty much all of Dallas and most of Fort Worth, and then Denton, I think, is one of the places that is outside the path.
Yes,
that right?
Denton is outside. Denton is going to be not over the top.
Awesome. Yeah, and Dr. Carlson, kind of thinking about this coming and where to see it, I guess what are some of the public safety things to keep in mind in terms of crowds, how to handle, seeing the eclipse?
Yeah, that's a great question. I think it's important to keep in mind that while we'll see a lot about the number of minutes of totality, and which here is amazing, right? And the place in the path where we are will have several minutes. And so often it leads people to think that this event is just one that's for a few minutes. But really, when you go to the eclipse, you very well might be there for hours. It's more of like a day-long event than a few minutes. So plan accordingly. You're going to be looking up at the sky, again, not directly at the sun unless you have the proper eyewear, which we'll all get to, but you're going to be outside looking up for hours perhaps. So have your sunblock, have your hat, have your plan according to crowds and where you're going to park. And it's also really important. We know from previous studies that have been done that once people are educated about how to protect their eyes,
that's really the best protection that we can have against eye damage, is knowing what to do. So talk to any children or young people who plan to join you in viewing the eclipse about protecting their eyes, how to do that. Be sure to plan ahead to get the proper eyewear you need ahead of time, so you can bring that with you to wherever you plan to view the eclipse. You can buy it right here at the planetarium, but be sure to have that ahead of time so you don't pinch it with something that isn't the proper kind of eye protection that could in fact cause eye damage.
Yeah, I think those are all good points that hopefully for a lot of us we can kind of just go outside and look up and be able to experience this. There'll definitely be kind of a lot of people coming into our area to experience this as well, so just keeping in mind that this could be kind of a long day thing and just a lot of influx of people. So yeah, I feel like we talked a lot about kind of the basics of the eclipse coming to our area, but there's also a really interesting research angle to the eclipse. So we'd love to get into kind of why researchers are so excited about this event coming here, in addition to just, all of us. So yeah, I mean, Dr. Breuer, why are, researchers excited about the eclipse, and what does that tell us?
Well, historically, all the way back to the ancient Babylonians, people took data, and there would be eclipses and other things that would happen that researchers used for millennia for, and then everybody added to it. And if you think about that 1878 eclipse here, there's a picture that shows 7 astronomers in a field that were ready to take all of their data. And so they had traveled here because we were on the path of totality. And if you think about 1919, the eclipse across Australia, that was when they proved Einstein's general theory of relativity, because they could see the sunlight bending with the gravity of the sun during the eclipse, and it proved the space-time, curvature of space-time. So there's all sorts of things to research, which is what our crowd's going to do on the day of the eclipse.
Yeah, absolutely. Dr. Deng, tell us more about some more of the research interests related to the eclipse.
Sure. Actually, solar eclipse is treated as a natural laboratory experiment for space physics, and typically researchers will use this opportunity to make measurements and conduct studies about the solar corona and upper atmosphere. By the way, during the April solar eclipse, I will be actually organizing a research workshop in the UTA Stadium, and will help space physicists to set up the instruments and make measurements of corona and upper atmosphere as well. Corona actually is very important for space weather. So during a corona mass ejection, we call it CME, a large, powerful hot plasma got blasted out of the sun, and it can cause a major storm in the space environment, which can interrupt the communication and threaten the power grid and also satellites in orbit. So the corona usually got monitored very closely by satellite telescopes using special technology. And do we have this slide?
I'm not sure if we have the slides. If you want to just keep explaining. We do.
Coming up.
Thank you. So, suppose if the slides come on, from that, what slide is coming?
So here's that telescope picture
But it's
that Dr.
okay.
Breuer was talking about.
All right, maybe I can keep talking. From the slide, on the left-hand side, a lot of structures can be identified. But those corona actually is difficult to see. And since simply the sun is too bright, without the special instrument, we cannot see it. And it only became visible to naked eyes during the total solar eclipse. And the left-hand side actually is right-hand side. Left-hand side is an image taken by a solar telescope. The satellite telescope. And the right-hand side is just a photo taken by some camera on ground during the eclipse in 2017. So if you look at the photo on the right-hand side, all those structures, the arcs, loops, and streamers, became vivid, which just is so exciting. And so basically, based on this comparison, we learned during eclipse, the observation on ground will strongly help us to understand the dynamic change of the corona and the different scales, such as from seconds to minutes, and different spatial scales as well. And meanwhile, the eclipse can cause a major perturbation to the upper atmosphere. Please advance to yeah.
Go one more slide over.
By cooling down the atmosphere temperature and also reducing the plasma density by the reduction of the solar radiations. And those perturbations actually traverse with the totality location and generates lots of atmospheric waves. And it becomes more clear in the movie. If we go to the next slide, no movie? Okay, that's fine. Anyway, it becomes quite clear in the modern GPS network observations. And those perturbations can interfere with the radio wave communication and cause potential issue for the communication as well. Therefore, the eclipse basically provides us a quite special, excellent opportunity to study what can happen if there's a sudden change and a localized change in the upper atmosphere. So we're so looking forward to that.
Awesome, yes, I feel like you brought up two really exciting points. One, the ability to see the corona, this really hot part of the sun's outer atmosphere that we can see with the naked eye when usually we need really specialized equipment, and scientists are really excited about learning more about that. And then two, these atmospheric waves, these perturbations that happen when the eclipse kind of moves across the country that scientists will be able to study and learn more about that as well during the upcoming eclipse, which is really exciting. Awesome.
I have a recent example. It was about 3 months ago. I got a call from our police department asking, they heard that from other agencies, some solar activity possibly affected the radio communication. So they were inquiring if that was the case, and I had no idea, of course, but I called Dr. Deng. She confirmed that there was indeed some intense solar activity that disrupted some radio communication on the surface of Earth. So these kind of studies are very important for us to understand what's going on. So especially for radio communication, for satellite communication, GPS communication.
Yeah, definitely a lot of real-world ways that those waves can impact radio, GPS, what you just described. Cool. And yeah, I mean, kind of getting into the history of how we've looked at solar eclipses. From Dr. Breuer, I'd love to hear a little bit more just kind of about how people in the past view solar eclipses and what some of the misconceptions we might have are about kind of what people in the past viewed them like and what they thought about them.
Well, first of all, I want to know how many of you have been away from DFW at night somewhere in the middle of nowhere in West Texas or New Mexico in a dark sky site? It looks completely different than what we see, right? That's what pre-modern people saw every night. And all pre-modern societies were sky watchers, but some more intensely than others. And if you think about it, people both mapped what they saw, because we all know those Greek constellations. So that's cosmography, right? They map the stars, they use it for agricultural cycles, they do it for calendars. But then they also look up and they form a cosmology, which is religious beliefs. And so for pre-modern peoples, you can't separate the heavens from their gods or the god or gods that they have. So if you think about one of the reasons why they can predict lunar eclipses and some can predict solar eclipses is that they watch the sky. They take note of when things happen and they start to see patterns because the sky is orderly and cyclical in nature. But what happens when something unusual occurs? Something like a comet, a supernova, or particularly solar eclipses. That's unusual, and they start to wonder about why do these things occur, and then they start to see even further patterns in what they're seeing. They also come up with reasons for what's happening. And I know that all of you have seen accounts of people thought that the sun was being gobbled up by a monster or a demon or an evil god. So the Chinese said it was celestial dragon that was eating the sun. But the Chinese also knew exactly what was happening, at least the learned people did. They were very good at astronomy. Some people who had sky gods believed that the gods were angry with them for some reason, and they better figure out what it was they were doing wrong and fix it, or else the next time maybe the sun wouldn't come back. But I think the ones that are most interesting are the societies that knew exactly what was going on, and then still saw some sort of divine revelation or something else that's happening. And I have two examples that you might think have nothing in common with each other, but they do. And the first are the ancient Mayas, who I think I could argue were one of the greatest sky-watching societies of all time, that had an incredible corpus of astronomical knowledge. They could calculate the solar year better than we could until the 1960s. So the only four remaining books we have of the ancient Mayas that weren't destroyed all have astronomical data in them. And they predict solar eclipses, which was hard to do. And they predict solar eclipses all the way up into our century, and they're accurate. So that tells you how important it was to them. But they still thought that it's the death and rebirth of the sun. And they would have rituals for renewal during eclipses. But at the same time, they also thought that they better write down what was happening politically, because some priest in the future is going to want to go and look at what happened in this eclipse. So the next time one occurred, they can tell their kings what they should do, right? Because time is cyclical. And so the other society that you might not think is doing this are the Europeans in the medieval period, even into the early modern period. And they understood what was happening in eclipses just like the Mayas did. We have Saint Isidore of Sevilla writing in the 7th century, Venerable Bede writing in the 8th century, accurately describing what is happening scientifically in a lunar and solar eclipses. And Bede was even saying, though, that this is not supernatural. It's not something eating the sun, but it's a natural phenomena ordained by God. But at the same time, medieval people also use the term signum for an eclipse, which is a sign. So they're looking for divine messages when there are eclipses. And just like the Mayas, they thought they were political messages. And so one of the most famous eclipses in the medieval period is called King Henry's eclipse in 1133. And it's called King Henry's eclipse because Henry I, the son of William the Conqueror, left England for Normandy on the day of a total solar eclipse, and he never returned. He died in Normandy, and people in England thought that that was a sign. And I'm a historian, so I bring quotes from documents. And one of the documents from the Anglo-Saxon Chronicle said that men were greatly wonder-stricken and were affrighted, and said that a great thing should come hereafter. So it did, for the king died in Normandy. They were lucky. They only had to wait 7 years for the next total eclipse. And when that total eclipse came in 1140, because there had been political chaos after the death of Henry, his son had died before him, so there was a succession crisis. In 1140, they had can you imagine, they had a total eclipse during Lent. And so obviously there are all the signs of what was happening. And then everybody started talking about it. And during the eclipse itself, and this is from William of Malmesbury, the obscuration of the sun also was so remarkable that persons at first feared that chaos had come again. And it was thought and said by many, not untruly, that the king could not continue a year in government. So they thought that King Stephen would now die, and they would have more political chaos. And unfortunately for them, he didn't. But that same eclipse in 1133 went over Augsburg in Germany, and they saw that as a sign of the sack that happened later that year of Augsburg, in which a good portion of the population was massacred, so that's a political event. And then other European accounts. There are accounts in Sweden, there's accounts in Scotland, in Germany, of the death of kings or heirs to the throne associated with solar eclipses. So they see solar eclipses as being political change. And so I think what's interesting here is that both the Mayas, the Chinese, there's a story of the Chinese that the emperors like to say that they could defeat the celestial dragons when they came, because their court astronomers told them that the eclipse was coming. Well, 2 court astronomers once did not, and the king had them executed because they didn't give them the right information. But, you know, this is the power of the court astronomers. And in the Middle Ages and even in the early modern period in Western Europe, the astronomers a lot of the astronomers we know today that were collecting all this information for the scientific revolution, they were actually court astrologers. And they collected this information while looking for signs to tell their kings and even the Pope what was going on. And so they were astrologers first and then astronomers, because there's knowledge and power in understanding what's going on. So imagine you could put a total solar eclipse in your prognostications for a king or a pope. Wouldn't that be cool?
I think you brought up so many interesting points there. I mean, just one, that a lot of these civilizations knew what was happening, and not only that, they had developed really advanced methods to track it. But even though they knew it was happening, kind of the eclipses were still really tied into the spirituality, the politics of the time, and really used as kind of an omen of good things, good and bad, which I think is really fascinating. Yeah, well, I'm really glad that we have that context, and I feel like the next good thing that's important to go into is just safety. So really what we really want to talk about here is just eye safety, protecting our eyes as we look up and see this really great thing. So really what we want to look into here is, do we really see an increase in eye doctor visits after a solar eclipse? Is that a thing that really happens? And what can we do to protect our eyes? So yeah, Dr. Carlson, would you love to get into that?
Absolutely. So interestingly enough, yes, in the countries that have studied this, there has in fact been an increase in eye damage and in optometry visits in the 2 days following the solar eclipse. And where they've particularly found it to be prevalent is with children and with young adults. So it's really important that we make sure that we educate our kids ahead of time about and have the glasses ready for them to know how to protect their eyes during the eclipse. But another thing that the studies have found, most of these studies have been in the UK. There were several after the 2012 eclipse, particularly the ones looking at children and the ones looking at there were about 70 people in the largest study, and in 84% of those, there was actual visual eye damage that was detected from having watched the eclipse. But we also know, some of the same researchers have also found that public health education is effective at reducing visual morbidity during an eclipse, from the damage that occurs during the eclipse. So we know that education and having the right eyewear, the right solar filters available is really important. So there's some do's and don'ts. I'll touch on a few of those, and then I'm going to turn it over to my colleague who can talk about it much more in depth than I can based on his work here at the Planetarium. So a few do's and don'ts of how to be safe to view the eclipse is, first off, you want to make sure that you have the proper eyewear. So that has to have solar filters in it. So you're going to need Eclipse glasses or an Eclipse viewer. Of course, you can buy the Eclipse glasses here at the Planetarium. It's important also that you don't just buy any old glasses. Sunglasses are not good enough, nor are the Eclipse glasses that you might find on a random internet site. Don't just go on Amazon and buy whatever. If you're not going to buy your glasses here at the Planetarium, then what we suggest you do is go online to a reputable site like the American Astronomers Society or NASA. And they have a list of reputable companies where you can buy your Eclipse glasses online. This is very inexpensive to do this. It's very inexpensive. It's just a few cents for a pair of the glasses that have been tested and that come from a reputable company. You want to make sure that you don't get counterfeit glasses that won't protect your eyes. And that can easily happen if you just order from any random site on Amazon, or if you go to Etsy and want to get like cool blinged out, little Eclipse solar glasses that are homemade. You don't know if the filter in those is actually the level that you need for proper sun protection. So those are some things to keep in mind. Also, other ways to view the eclipse safely is, of course, on TV or here at the Planetarium at UTA. So those are other things to keep in mind. You want to make sure that you don't look at it through your phone. That's also not a great way to do it. My colleagues have some ways that you can do that in a safe way, but don't be looking through the viewfinder of your phone either. So be careful. The reason it's so important that we protect our eyes is because if you look at the sun, and again, while the eclipse is only just a few minutes of totality, which is a big deal, right? But you're going to be staring up at the sky for probably much longer before the eclipse happens. So we want to make sure that you're not looking up at the sun during that time, because what can happen is two different ways that this causes damage. And in one of those ways, it's permanent. The first way that looking at the sun without proper solar filters can cause eye damage is with regard to, it's like a sunburn on your cornea, okay? And that will heal. It'll be uncomfortable, you'll have some blurry vision, but it will heal. However, the other way that looking at the sun causes damage, again, from the UV radiation, is it actually can burn your retina. So if you think of the eye like a camera, then the retina is the film. And you know when you corrupt the film in the camera, now you've corrupted the picture. So that nerve that brings the photo to the brain, that film is now damaged. And that damage will likely be permanent. So it's very, very important to not burn, certainly not burn your retina. Let's try to not burn our cornea either, so be sure to have the proper eyewear to avoid any kind of solar retinopathy of any kind.
Awesome, yeah, I think that was a great overview of just one, what actually happens when you look at the sun, and then also, you know, what are some ways to protect your eyes. And Dr. Gurdemir, I'd love to hear more from you, and also kind of, let's say you're not able to find the glasses and it's the day of the eclipse and you're like, oh man, like what can I do? Like, are there still ways that you can look at the eclipse or indirectly view it, even its shadow, even if you don't have the glasses?
Yeah, I was also doing some research on the damages of the eye, especially during the eclipses. That is true that the eclipse, certainly the damages are increasing. Numbers are increasing after the eclipses, and because if you look at the sun directly during daytime, during normal time, out of eclipses, it's gonna be okay, even if it's like 10, 15 seconds, even sometimes longer. It is going to be okay because our eyes are equipped with some iris mechanism, so we dim our eyes as the environment gets brighter. And this is something we experience in the planetarium because this is low light environment. All the eyes are actually going wide open. And that's why we have this vestibule area. Before we take you to the direct sunlight outside, we put you on a vestibule, and then you see like a short hallway, and then you are going outside to the bright daylight. If we made a door right on that wall, and you would be just outside right away, and it would probably it wouldn't be comfortable for your eyes. So during the eclipses, especially total solar eclipses, for that about 2-minute period, the iris is going to be actually wide open because we are going into dark environment. And then, if we are just watching the eclipse, when the sun starts revealing, right? And that is going to be faster than the iris adapts itself for the light environment. So that is going to be, that is causing the major damage for the eye. For that reason, the eye protection is a pretty important matter. And also, not only like having any eye protection, as my colleague mentioned, that you need to make sure that you have a quality filter, and it is most of the time. It's one of the commonly asked questions. I bought an eclipse glass for the past eclipse 2 years ago. Can I use the same thing? Well, if you are sure you kept it in perfect condition, probably yes. But why risk it? I mean, just a couple dollars or sometimes free. Just buy eye protection. And if you don't have eye protection, there are other ways to look at it safely. First of all, there's a lot of hoax out there, just undeveloped photographic film, pop-tart paper, or no, I mean nothing else. Nothing else works. Some even talking about some welder glasses, welder masks. I don't know what the grade is, but still, it is, I think, just overkill for an event like this. The best way is just getting access to one of those cheap or free paper glasses from a reputable source, because there are some out there who made it, we don't know. Are they good enough? We don't know, because the ones we have is coming from a company who has been manufacturing these for years in the United States. And you cannot see anything if you put it on, unless you are looking directly to the sun. You cannot see anything because it filters more than 99.9% of the light. So it is just a tiny transmission. So you need a glass or the filter like this. The filters are easy to damage, even like a fingertip nail strike or a sharp object is touching them. You put your cup or mug on top of it, it's going to damage. You carry it in your purse or in your pocket, it is going to be damaged, so they need to be handled very gently. You need to make sure there is nothing visible, no scratches or nothing when you look through the daylight. So you need to make sure everything is just in perfect condition before you use it. So this is important. If at the eclipse day, let's say you couldn't get hands-on, you couldn't put your hands on a pair of glasses, and you don't have anything else. One way of it will take time, you can manufacture a pinhole projection, but that's a whole different thing. But we'll use some technology and we will live stream the eclipse to the internet, so you can pull off your phone, not point your camera to the sun. This is not what I'm talking about, just watch it from the screen safely. And also, that brings an important fact too. If you are using a phone, a camera, or first of all, if you have a pair of telescope, I mean the pair of binoculars, or a small or big telescope, does not matter. The sun is very powerful. The sunlight is very powerful. If you are using an optical device, and if you are using your eye, it will for sure blind in the matter of, I don't know, seconds. It's going to be, I mean, it's a very dangerous thing to do, unless you have a proper protection, proper filter on it. If you have a camera, do not point it to the sun, because it will burn the sensor. And if you have, like you can do, probably if you haven't done it, you can do an experiment. Just get a pair of reading glasses, and you can actually start a fire on a paper using the sun underneath. So the sun is, sun damage is, very, very quick. So yeah, if you don't have a pair of glasses, best way is watching a live stream or watching the projection. Again, I cannot just stress enough the eye safety for that eclipse.
Yeah, all great points. And we're coming up just a few minutes left in the discussion, so if you have a question that you've written down and you'd love for the panelists to answer, this is a good time to pass those down to the aisles. And we'll have volunteers coming by to the aisles just to collect those so that we can answer those. But yeah, just a few minutes left, so I'll just kind of ask one question just for all of you guys, which is just, if people were to take away one thing from this discussion, what would you want that to be? And Dr. Deng, would you like to kick us off with that one?
Enjoy it, and keep in mind, always physics and science behind the fantastic phenomena. Always question about how and why, and I think the curiosity just propels the science inquiry.
Awesome. And Dr. Carlson?
This will be a very memorable and really a once-in-a-lifetime experience. So enjoy. Treasure the moment, but do it safely and plan ahead so it can be done safely.
Awesome. And Dr. Breuer?
Well, people have been watching solar eclipses from time immemorial. So stop and think about how you're part of this human history. And it doesn't matter if you believe in divine messages or celestial dragons or the power of science. You're viewing something that people thousands of years ago looked at, and thousands of years from now are going to do the same thing, and you're part of that continuum. And that's kind of interesting to me.
And Dr. Gurdemir?
Well, if you are taking one thing, I would want to be just remember the planetarium, how great it is.
Awesome. Well, yeah, thank you guys all so much. We have a lot of really great questions here, which I'm looking through. But just to kick us off, one thing that we kind of brought up was how you probably shouldn't point your phone at the eclipse to take a picture, but obviously taking a picture and capturing the moment is something that we all really want to do. So what are some ways that we can get pictures of the eclipse without ruining our equipment?
Well, you can use those solar filters, even the glass you get. You can put it in front of the camera of the phone, and you can. It's going to be a little difficult because you are not going to be able to see the sun unless you are pointing right at it. But still, it is the best way to do it. You can protect your equipment. If you are taking just a few images for a short time, you are just pointing your phone and just snapping pictures. It's going to be fine. I mean, your phone is going to survive for longer period of time, because what's going to happen is it's going to just burn the image of the sensor of the camera and causes the internal temperature of the phone to increase, which potentially can damage the electronics. But if you are taking just a few pictures at a time and letting your phone to be cooled down, it is going to be likely to be fine. But again, the best way, especially if you are using professional camera, because they have bigger lenses and bigger aperture in front of the professional camera, that is going to be less safe for the sun because it collects more light in short amount of time and it damages the sensor. It's not going to damage the eye unless you are looking through this finder piece. Not a good idea. Actually, you need to cover that too. You need to make sure if you are pointing your camera, even though it is filtered, you are pointing your professional camera with finder peep window to the sun. You need to make sure that that peep window is blocked, because the sunlight will still transmit. And most of the time, actually, even though they are looking at the digital screens nowadays, they are burning their skin because they don't realize that the light transmitted from the peep window reaches to the skin and burns it. So you need to be careful on that too.
Great. And one of the questions that we have here that might be helpful is just, will the sun be immediately overhead at the time of totality, or where in the sky can we expect to see the sun?
Well, it is going to be in the south direction, where the sun's path is always be, and because it's going to, the totality is going to happen in around 1:40 p.m. So it is going to be high in the sky, not like directly overhead, but it's going to be fairly high in the sky.
Awesome. And another question that we have kind of related is, some people are wondering, one, what we know about how animals react to the eclipse, and also, should we keep our pets inside? Is it okay to have them out? Safety in terms of that.
My understanding, and not a veterinarian at all, but my understanding about this is that there's not the same risk to animals as humans, because at least my dogs don't just sit there and look up at the sun or the sky. And so animals are not going to be looking up at the sun for any particular reason any more than they normally would be looking at the sky. So that type of damage we don't have to worry about. Also, our pets, our domesticated animals, they're more concerned with their human schedules than they are with what's going on sometimes in nature outside of like thunderstorms and big noises. So typically, my understanding is that your pets will not be scared like when there's a thunderstorm or something like that. Yes, the sky will get dark, and that might cause them. Some animals might get a bit scared because it's unusual, but not anything like fireworks or a thunderstorm or anything like that. Now, there have been places, and I don't know if this would happen here, but where they do shoot off fireworks during solar eclipses, and in those cases, we know the animals get very frightened, as they would just like the 4th of July. So that's my understanding. And then also, one interesting thing is that when it gets dark, when you're in that moment of totality, and the temperature is actually dropping, that also can raise some awareness for animals, because obviously there's a very tangible, if you will, or noticeable physical change in the environment when that temperature drops. And mosquitoes like to start biting then because they think it's night. So take your bug repellent with you if you're going to be watching the eclipse. Just a heads up.
Honestly, as someone who mosquitoes love, that's very good advice. Thank you. I will be doing that. We have a lot of questions just kind of about where the best view is to see the eclipse. So some people are wondering kind of, is the view 100 miles from here, any better than here? Where's the best place at UTA? Kind of, what do we know about kind of different areas within the path of totality, and is there kind of a best place to view it?
All right, so as soon as we are in the totality path, the changing the location will be just increasing or decreasing the totality duration, totality time. So we are going to be experiencing this for about 2.5 minutes. And I think that the maximum you can get is going to be a little more than 3 minutes if you travel, which in my opinion is not worth. But as soon as we are in the totality, I don't see any reason for traveling.
Yeah, so that makes sense. Essentially, kind of anywhere in the path will have a good view. It's just kind of how long the actual totality will last.
Yeah.
Okay. Awesome. And sorry, the other question. Oh yeah. So I think also some people are wondering, we know kind of what totality looks like before the eclipse happens. When we're looking up at the sky, like what are we looking for? What will we see basically in the sky before the actual totality happens, and how can we know when we look up at the sky, oh, it's kind of the eclipse is starting? What will that look like?
Well, the eclipse will start with partial eclipse because, out of a sudden the moon will be entering inside of the sun's circle, which will be blocking the sunlight. But that is going to be not noticeable unless you are looking at the sun using an eclipse filter or eclipse glasses. So like we recently experienced partial total or annular solar eclipse just back in October, which about more than 70% of the sun's surface was blocked by the sun. Actually, more than 90% was blocked by the sun during the annular eclipse. But still, there was plenty of daylight. So unless you knew that that was a solar eclipse day, or you realized that some tree leaves are acting like a pinhole projection and creating eclipse pictures on the grounds, you wouldn't know there was an eclipse going on actually. But this time it's going to be different. It will start partial. It will enter into the sun's circle, blocking more and more sunlight. But this time the alignment is perfect. For 2.5 minutes, the moon will block the sunlight, and then it will turn into nighttime. We can even see stars. There was even a famous Einstein's experiment how the shifting or changing or light bending around large objects was proven, because when he just expressed this theory, people said he is crazy. But that was proven during solar eclipse, because that is the moment you can see the stars around the sun, and it was proven that the stars around the sun indeed shifted their positions because light was bent. So we can see stars if the conditions are clear, and then this is going to take 2.5 minutes, and then for another twilight, and then the daylight will start recovering pretty quickly after this. But sorry,
one phenomenal thing will be, again, I have not experienced in person a total solar eclipse because always when solar eclipse is happening, I was traveling on the other direction in the world, unfortunately. And this time it's coming to me, and I'm not going anywhere. I'm not traveling. So that corona is pretty. People say they were able to see the corona layer of the sun. So this corona has nothing to do with the disease we have gone through. This is the name of the gas layer around the sun, which is normally not visible because of the sunlight doesn't allow it. But when the sunlight is blocked, the sun itself is blocked, then we can see that gas layer around. And that gas layer, the seeing and feeling of that gas layer, people says this is unforgettable experience for them. It's not working?
Nope.
You can take this one.
Thank you. I just want to add in about traveling for the eclipse. So the biggest uncertainty may come from the weather. If you do see somebody travel for the totality, the number one reason could be they're trying to get rid of the cloud. So keep checking the weather 3 days before the totality. We need to become more accurate than now, and keep eyes on it.
Right, having clear skies is definitely one of the most important things. Awesome. We have a couple questions about glasses. So one thing people are wondering is kind of what should I look for on my glasses to make sure that these are safe and not counterfeit? And then also, are there wear-over glasses that people could wear over normal glasses that they wear to see?
Well, over normal glasses are perfectly fine. The only thing is the eclipse glass should be on the most outer layer. It shouldn't be behind your actual glass, on top of the actual glass. So the first sunlight hits the your solar filter first. And the buying those, unfortunately, there is no good method, even though I know some vendors are providing ISO and CE certifications and coming up with some spec sheet of lab-tested paper glasses. Well, that sounds too good to be true for me, going through lab tests, expensive lab tests to sell these cheap glasses. So the only the way I can describe is that just buying or getting them from a reputable person or entity or company, like a planetarium, like a city, or like a NASA or some physical astronomical societies, scientific societies on the internet, astronomy clubs, because those are probably going to know where they are getting or where they are sourcing glasses from. And unfortunately, internet and places, some online shopping places, I would question. I don't know, which one would be reputable, because those are printed on a paper. The paper part is printed on a paper, and there is just a filter stuffed on the lens part. So you can print anything you want on the paper part. You can print, this is certified, this is lab tested, this is federal government approved. You can write anything you like. That doesn't mean that it is actually what it is.
Yeah, I think that's helpful. So kind of looking for reputable buyers, particularly like the list on the American Astronomical Society website is a good...
Yeah, International Astronomical Union and American Astronomical Society on their websites list some of the vendors. They are not including all the vendors, but some vendors that are known to, at least they made glasses before. They made glasses for some long time. They just started their business yesterday because solar eclipse was coming. So those companies are, I think, more reliable companies. There are several of them. There are probably in the United States at least 5 companies exist, and internationally there is more. But yeah, I would check these sources: American Astronomical Society website and International Astronomical Union website for eclipse glass resources.
Awesome. And just one question related to that is, during the eclipse in April, is there a moment where you can take off the glasses safely, and when will we know when that is?
Yes, part of the moment. Actually, during the partial eclipse, this is the moment we will be using our glasses. But when the totality starts, glasses will be useless because it's going to be dark, and this is the moment you would like to experience using the real eye without any filter. But as soon as the eclipse is over, the glasses are back on. So this is the dangerous part. If you wait too long enough, well, you will know that you on one part you will see some light leaking, and this is the time you start wearing your glasses back. But the totality 2.5 minutes should be experienced glassless because you cannot see anything with glasses anyways.
Yeah, I think that's a good point to know when you can take it off and enjoy the totality with everyone. And we just have time for one more question, which someone is wondering about the disruption in neutrinos during a solar eclipse. So they're wondering what impact that could have on the Earth's magnetic field and us.
That's a Dr. Deng question.
Magnetic field, that's an excellent question. The major field, magnetic field, is quite strong, and even during a major solar storm or major event, the perturbation of magnetic field is only 10% of the Earth's magnetic field, so wouldn't cause major disaster, but since the solar radiation is going to be reduced, lots of complex reaction will happen in the upper atmosphere, can cause some dynamical change, plasma change, and current change. Definitely will feel, you'll see some signal on the ground. If you have a accurate magnetometer, which is an instrument to measure the Earth's magnetic field, you will see the perturbation. It's measurable, but it should not be a major concern.
Awesome. Well, that brings us to the end of the panel, but thank you so much to all of our panelists for sharing your expertise with us, and thank you to all of you guys for coming to learn more about the eclipse. Yeah. Awesome. And thank you so much to the Planetarium for hosting us as well. Hope that you guys learned something. I definitely did as well, listening to everyone, so hope you have a great rest of your evening.